if you've forgotten a little bit about factoring, you need to review that. So this is going to be the integral from 0 to 1, x minus 4 on the top, and the bottom factors into x minus 3, x minus 2. That could actually be a little tricky factoring problem because you have factors of 6, 2 times 3, and 2 plus 3 is 5, and you got 6 times 1, and 6 minus 1 is 5, but only one pair works. It's a 2 and the 3 for this one. All right, so I got this, and now the partial fraction. I'm just going to write, I'm not going to write the integral sign, I'm just going to write the fraction part. So because I'm not writing the integral sign, this is also something, when I'm grading the papers, I'm going to look for this. If you put an equals right here, you're saying it equals what you wrote previously, but that's not true. I didn't write the whole integration part. Let me get rid of that equal sign. But x minus 4 over x minus 3 times x minus 2 does equal a over x minus 3 plus b over x minus 2. Previous problem, I combined them, I equated coefficients. This time, I'm going to take a little different step. I have this equation, and I'm going to multiply both sides by x minus 3 times x minus 2. This is probably a little bit shorter. Because it's an equation, I can do that. What happens on the left side? Cancels. I got x minus 4. On the right side, a over x minus 3 times x minus 3 times x minus 2 will be a times x minus 2. What about the b? b times x minus 3. And that looks a whole lot better than what I did on the previous problem. There's something else you can do right here. You might not have to do the system of equations. You could, at this point, say this. Well, the book calls this an identity, and it is. I could pick numbers like let x equal 2. Plug it in for every x. What is that going to do? Look at this. 2 minus 4 equals a times 2 minus 2 plus b times 2 minus 3. So I end up with negative 2 equals a times 0 plus b times negative 1. So it's wiped out the a, and I can say negative 2 equals negative b, and then b would be, b is 2. And I can do the same. I can say let x equal 3. Well, I could put in the 2 for b at that point, but I'm going to pretend I didn't notice that. Let x equal 3. 3 minus 4 equals a times 3 minus 2 plus b times 3 minus 3. So I'm going to get negative 1 is a times 1 plus b times 0. You don't have to write all that. Negative 1 equals a. And sometimes that's more efficient than doing a system. Sometimes you might do this technique and then take what's left and do a system. You need to practice the problem so you can figure out what's the best way to go. Well, now I have, I probably got room to, at this point, come back up here and, okay, here's my equals. And I'm going to kind of separate my work here. from the integral. So we have, oh, I don't know if I want to do it all right here. This is a definite integral. So I'm going to have a little bit more to do. So a over x minus 3, a was -1, plus b was 2 over x minus 2. There's my calculus problem now. And then I'm going to go to a new page because of it being a definite integral. So we're going to have 0 to 1. I'm going to write the 2 over x minus 2 first, and then I can just write minus 1 over x minus 3. This is two separate integrals. What's the antiderivative of the first part? There it is, 2 times the natural log of the absolute value of x minus 2. And the second part is the natural log of the absolute value of x minus 3. I don't need the plus c because it is a definite integral. We're going from 0 to 1. So I will plug in the 1 for x, 2 times the natural log of the absolute value of 1 minus 2, minus the natural log of the absolute value of 1 minus 3. There's the first part. I'm going to use brackets because it's minus everything I get now when I plug in 0. So that's 2 times the natural log of the absolute value of 0 minus 2, minus the natural log of the absolute value of 0 minus 3. So 2 times the natural log of the absolute value of -1 minus the natural log of the absolute value of -2. This minus sign distributes. So minus 2 times the natural log of the absolute value of -2 plus the natural log of the absolute value of -3. I kept the absolute value signs. Let's go ahead and do the absolute values of those numbers. 2 times the natural log of 1 minus the natural log of 2 minus 2 times the natural log of 2 plus the natural log of 3. The natural log of 1 is 0. And look, I got these, I guess I could consider them like terms, but they're all constants. Look, so -1, that's because I can put a 1 in front of that. -1 times this. Did I make a mistake? I see some hands up. Questions, okay. Let me finish it up and then we'll do questions. -3 times the natural log of 2 plus the natural log of 3. Oh, that should be -3, yeah. This part's 0. Questions?
I think that's negative natural log, which was in the last section.
Which one?
The one written over, yeah, that would be negative natural log.
No, because this minus sign distributed.
Oh.
Yes. Yes.
Why don't you break it up into 2 integrals and do the last one?
I could have.
Okay.
I could have done that. Sometimes I'll break it up into 2, and sometimes I'll just go ahead and work it, and sometimes it's a good idea to break it up, and sometimes it doesn't really matter. And so how do you know what to do? Practice.